guess I'll get going then.
Okay. I'll just do a quick introduction. Eoin has been going on to the reproducibility meetings and is interested in some issues with philosophy of science that might be applicable to all of us, especially those of us who do anything to do with pre-registration. So I'll let him speak for himself, but yeah, hopefully over the next few years he'll get a bit more involved in TARG and some of the meta research and improving science stuff that we're doing here. And I think his talk should be about half an hour long, and then we'll have time afterwards for question and discussion. And hopefully also hitting the pub this evening as well afterward. So I hope to see a lot of you there. I think a lot of us can use it during coming back from Easter break. So without further ado, take it away.
Yeah, thanks, Jackie, for that very nice introduction. Yeah, thanks everyone for coming to listen to me today, and yeah, thanks also Marcus for the very kind invitation to speak today. So I'll start with a quick summary of today's key points. Quite sure how to use the actual
Click on it and then just
slides here to move on to the next
You
slide.
click mouse click there.
Nice. There we go. So yeah, we're going to start with a quick summary of today's key points. So what I'm going to show you today is that the error control version of confirmatory exploratory distinction, this idea that we want to pre-register our analysis to do a test that has low error rates, is actually agent relative. So two scientists can have the same data, the same background information, the same set of calculated test statistics such as p-values and so on. And also they can be examining the same hypotheses. And this can facilitate an analysis which is confirmatory for one scientist, but not for the other. And this is the case, as we will see in detail later, because whether an analysis is confirmatory or exploratory for a particular scientist depends on what hypotheses they would have accepted and rejected in response to the full range of possible outcomes that might be observed in the data. And this is something that can vary from one scientist to the next. And this illustrates the kind of philosophical objection that you might raise to this confirmatory exploratory distinction that someone like Rubin might want to raise, who wants to reject this confirmatory exploratory distinction. I don't personally think it is much of a problem, and I'll be showing that despite this little problem, there are good reasons to use pre-registration to conduct confirmatory tests. It's one sense in which we can avoid fooling ourselves by pre-registering our analysis. But fortunately, given the controversial nature of this confirmatory exploratory distinction, we will see at the end of the talk today that there are quite a few other potential intrinsic benefits, the term I'll be defining very shortly, potentially attached to pre-registration, which require no recourse at all for this controversial confirmatory exploratory distinction. So, of course, I'm talking about pre-registration, but more specifically, I'll be talking about pre-specification as it's defined here. So this is one aspect of what's involved in properly using the scientific tools of pre-registration and registered reports. It involves writing down an analysis plan outlining how certain aspects of the study will be conducted prior to collecting or observing some portion of the data for the study. And then specifically, it's doing this in a way that facilitates actually forming the intention to follow through on the plan. So it's analogous to if I wanted to go on a diet, and maybe I would have a tendency to say, well, no, I don't do it. But actually writing down a planned diet could then cause me to formulate the results to actually follow through on the plan. And then the other key aspect of pre-specification, which Daniel Lakens has highlighted, is that it clearly indicates to ourselves and others that we have actually had this particular intention to follow through on a plan. Pre-specification for the applications that I'll be talking about today, it doesn't need to involve any predictions made by a researcher about the actual results of any experiment. And so today's question is then, what are the potential intrinsic benefits of pre-specification? These are benefits which it is not feasible to achieve through other means. So for example, a lot of people talk about how pre-registering an experiment might encourage researchers to more carefully think through their analyses. And this would be a mere positive externality because while it's a potentially a big benefit, but it's something that could be achieved through some other means. And I do strongly suspect that most of the benefits that we're currently getting out of the contemporary practice of pre-registration are mere positive externalities. So then you might ask, well, why do we care about intrinsic benefits? And I think a key reason is that, so if there are these intrinsic benefits attached to certain ways of using pre-specification, then this means that even the very best studies can actually benefit from using it. So then if you're saying, well, I'm going to attribute more credibility to a certain researcher's analysis because they pre-specified, it doesn't come with this kind of implicit implication that maybe they're susceptible to questionable research practices or maybe just poor scientific reasoning. So then it boosts the kind of the rhetorical case that we can make for pre-registration. And this distinction between Mayo positive externalities and intrinsic benefits is something that Daniel Lakens, a psychologist, some of you may know, has already drawn in what I believe is quite influential recent paper. And he uses slightly different terminology but the same distinction. And in that paper, Lakens is popularizing this idea that sort of the official intrinsic benefit of pre-registering a study is to facilitate severe tests in the sense defined by the philosopher of statistics, Deborah Mayo. And I do think Mayo's work is very good, but this undersells the case for pre-specification because, as you will see, there are other potential intrinsic benefits that do not imply this very controversial view of Mayo's. So why does Daniel Lakens think that we need to appeal to this philosopher's ideas? It's because he's a member of this school of thought here, where we want to do confirmatory analysis in the error control sense. So a quite vague definition of that would be that the test is confirmatory if the relevant error rates, potentially including family-wise error rates that are associated with accepting and rejecting hypotheses on the basis of the test, are known to control at a low level. And you probably may have seen this kind of idea floating around in the literature. You know, inferential statistics are only valid when they're applied to confirmatory analyses, and otherwise p-values may lose their meaning due to this unknown inflation of the alpha level. And the issue is that terms like unknown inflation of the alpha level, controlling error rates, running a test, these are all quite ambiguous. And Mayo has provided the most sensible interpretation of what we should mean by these. If we don't appeal to Mayo's views, it's going to be unclear what we mean when we say that the exploratory analyses have this unknown inflation of the alpha level. And it's also going to be unclear why we shouldn't take sets of confirmatory and exploratory analyses and control for a combined family-wise error rate across those sets of hypotheses. So, what Mayo's view does come with this little drawback that I'm going to show, which is that two scientists can have the same data, the same p-values, the same background information, but one will have run a confirmatory test of the same hypothesis and another merely exploratory. And yeah, so this is the kind of view that would kind of give fuel to the fire for someone that wants to take this Fisherian interpretation of p-values, and we see it in slogan form here with this quote from Ronald Fisher. If we have a low p-value against a null hypothesis, then either an exceptionally rare chance has occurred, or the null hypothesis is not true. And the key issue here is that p-values are this kind of agent-independent measure of the evidence against a particular null hypothesis. And so this Fisherian view has been advocated in a number of papers by Mark Rubin, who's also, as some of you may know, one of the more prominent critics of pre-registration. He thinks it's at best a waste of time, potentially even harmful. And because when you take this Fisherian interpretation, it implies it leaves no place for this confirmatory exploratory distinction. It makes sense that you might then think that there's no intrinsic benefits to pre-specifying, but we will see later that this is actually would be a mistake. So what are we doing when we have these philosophical interpretations of statistical methods or philosophical theory about evidence? What we want to do is we want to give a general description of the conditions that are kind of implicitly characterize what is already best scientific practice. We're definitely not trying to tell scientists how to do their analyses because they know better than anyone working in philosophy of science. So then when we have this implicit, when we have this characterization of the general principles that make for good science, if we both agree on these principles, then it allows us to potentially make these more clear, more precise arguments for a controversial methodological proposal like pre-registration. We could say we both agree that this is a kind of good definition of evidence, and if you notice that actually if we pre-register, then it can increase how much evidence we have or otherwise. So now with these preliminary remarks out of the way, we can jump into this mostly fictional motivating example that I'm going to be considering. It's an example that's set up to kind of very clearly illustrate some general points. And so we have this kind of vague Freudian hypothesis that some vaguely specified way of parenting may have some vaguely specified benefits. And then someone comes along and they say, hey, I've got these 460 outcome variables. And they're claiming that this is a representative example of the implications of this Freudian theory. These effects are representative examples. And then we can imagine a somewhat Orwellian society where they've actually set up a randomized controlled trial in which parents are more or less forced to do Freudian parenting or control parenting technique. And this directly tests then something like this hypothesis, which is that the Freudian intervention will have an important causal impact compared to control in the target population, which is actually predicted by Freudian psychology. What do I mean by an important impact or an important effect? Well, it's a genuine causal effect of the intervention compared to control, which has a Cohen's d effect of 0.21 or greater. That's our minimum effect size of interest. And then it would also have to actually be predicted by Freudian psychology as well, which all of the outcome variables we're looking at are. So we're imagining a fairly ideally conducted randomized controlled trial. We've got this huge sample size, and we've got random and representative sample from the target population. You'll all know a lot more about how to properly set up a randomized controlled trial than I do, so you can fill in whatever details you know would be necessary to properly facilitate a causal inference in the trial, just to assume that they're all in place. And so then Sam has this pre-data analysis plan. Well, later we'll be distinguishing between the pre-data analysis plan and the post-data testing rule that we can say we're following. So it's just, you'll be familiar with this kind of rule. It's for each p-value of 0.05 or less against a null hypothesis, saying that the true Cohen's d treatment effect is less than the minimum effect size of interest. Sam will consider this to be a statistically significant result. It's just a piece of terminology, but then importantly, this will come with this corresponding inference that there is an important effect of the intervention on that outcome variable. And then the results come in, and there's only 11 out of 460 statistically significant effects. So, including on, for example, good school relations, high social standards, little nail biting. This actually is a real data set in which they tried to find support for Freudian psychology, and they only got 11 out of 460 statistically significant results. Of course, I did make up the randomized controlled trial part. So then what Sam's inference is that there is an important effect of the intervention on each of these individual variables, and then they come up with this modified version of Freudian psychology, which would imply, they claim that these 11 effects are representative examples of the implications of that view, and then the other non-significant variables aren't representative examples of the implications of this modified Freudian hypothesis. And so you're probably all thinking something like this, which is that even if all of the null hypotheses are actually true, it's very likely to get 11 or more statistically significant results. So my calculation for this was that we assume all the p-values are statistically independent. We assume all the effects are just a tiny increment below the minimum effect size of interest. And then the probability of 11 or more significant results would be exactly 99.8%. This is an upper bound estimate though, because if the true effect size is substantially lower than the minimum effect size of interest, rather than just a tiny bit lower, then this probability will actually be lower. So it's an upper bound estimate. And Sam is no one is going to be disputing this mathematical fact at any point, but Sam is saying, why does this mean I don't have evidence for each of my 11 important effects that I've inferred? And they can say, I don't care about this family-wise error rate across the full set of 460 null hypotheses. The simple type 1 error rate associated with rejecting each individual null hypothesis is 0.05 or less. So why can't I just use that as my evidence in favor of each of these individual effects? And to give a clear answer to this, it will be helpful now to turn to Mayo's Error Statistical philosophy of statistics. It's a subtle but important refinement of the mathematics and the explicitly stated aims of name and Pearson methods, which Mayo has convincingly argued kind of implicitly characterizes how these methods are already used in the best case scenario. And so once the data are already in, Mayo's error statistics directs us to try to use our statistics to answer this question here. By accepting this hypothesis based on this data, how good a job have I done ruling out the possibility that I may be making an important error? And then a slightly more precise version of that question. It's a bit of a mouthful. We'll sort of see now when we go through the example what this means, but it's given the observed data by following the rule for accepting hypotheses that I'm currently following. Is there a low probability in the particular case at hand that I would be accepting this hypothesis H1 or some other hypothesis that's relevantly similar to that hypothesis if the claim is associated with some important inferential error or truth? So this is Mayo's question. And then what determines the answer to Mayo's question for a particular hypothesis is how severely have we tested that hypothesis? And there are a number of things that determine that. So we've got our observed data and our test statistics, such as p-values that we've calculated. you've got the hypothesis itself, and then the corresponding null hypothesis that's implied if we say that hypothesis isn't true. And then there's a certain testing rule, a rule that we're following in case of hand for accepting and rejecting hypotheses in response to the various outcomes that could have been observed in the data. And then there's one final thing, which is the relevant error that we might make. So when we're rejecting a particular null hypothesis, the relevant error is not necessarily just that that hypothesis itself is true. It's we can think of it as this kind of type 1 error rate for a combined null hypothesis, including quite a number of different individual nulls in addition to the one at hand. And then, in order to know what testing rule we've just followed, when we've accepted or rejected a hypothesis on the basis of the data, we need to know what inferences would we have made in response to the full set of possible outcomes that we could have observed. And then we're now going to run through a numerical example of the current case to show if we can determine how severely the SAM tested their particular claim. So test each of the claims that they're inferring. So this is the rule that they're following. If there are 11 or more statistically significant effects from the set of 460 calculated p-values, infer that each of these indicate an important effect. And then the relevant error. So to determine what the relevant error is, we have to decide on what the actual goal of our inquiry is. But we might think that the goal is to control this particular error, which would be inferring that there's at least one important effect of the intervention, even though there are no such effects. And then we have this set of outcomes of following our testing rule, in which some inference or other possibly leading to making the relevant error is actually made. And in this case, it's a very large set of outcomes. So it's the set of all sets of observed effects out of 460 variables, in which there are 11 or more statistically significant results. And then we've already seen the maths for this calculation. By following this rule, there is potentially as high as a 99.8% probability of inferring that there's one genuine effect of the intervention under the assumption that there are no such effects. So now the multiple hypothesis testing police finally have an answer for Sam's so what question. It's that by accepting that there's an important effect of this intervention on, say, good school relations, you've done an exceptionally poor job of ruling out the possibility that you're committing the important inferential error that you said is actually the goal of your inquiry to avoid. And so you therefore have not severely tested any of these individual effects that you've inferred, and so you have no evidence for any of these individual effects. You haven't done a proper test of the effects. So in this case, the error probabilities are known to be low, or they're known to be very high. But more realistically, what might happen is there's the unknown error probabilities. So we can imagine Sam just has a look at the data, and then they decide what analytical strategy is reasonable on the basis of the observed data. And if they do this, well then the issue that we have is there's no longer this sort of nice neat set of possible outcomes. Rather, what there is there's an unknown set of possible outcomes, which might lead to the relevant error. And then the probabilities of these outcomes under a null model are also unknown. So, and this is an issue that could actually arise even if Sam was just testing one hypothesis. Say they were only looking at the effect, looking for an effect of the intervention on good school relations. And suppose what they're going to do is they're going to look at the data, they're going to determine what model to run based on characteristics of the data. Well, then what this means is that if we keep repeating that experiment and they keep doing that, they'll use varying analytical strategies in each repetition of the experiment. And then what this means is that this potentially inflates the probability of rejecting that null hypothesis under the assumption that it's true. So so this problem doesn't just apply to these big data mining exercises. It applies to any case where analytical decisions are made on the basis of the observed data. And this is the sense in which the exploratory analyses have this unknown alpha inflation. So,
sorry, could you just explain that again?
Yeah,
the last part of that. It's not just that the data mining is sort of.
Yeah, so what we saw in the example we're looking at was kind of this ridiculous data mining exercise. There are these numerous hypotheses, and there's a very large family-wise error rate across those hypotheses, right? Yeah. But if we imagine that there's only one hypothesis, then the statistician Andrew Gelman and Eric Logan had this garden of forking paper where they refer to what they call the garden of forking paths problem. So what this means is that let's just say my hypothesis is it's that there's going to be an effective intervention on good school relations. And let's say, but there are different models that I could run that might be taken to constitute confirmation of that. So
Right.
I might look at the data and maybe I see that, oh, look, it looks like there's actually a big coincidence here for females, but not males. So then I run this interaction effect, whereas in another repetition of the experiment, where I follow that rule of having a look at the data and then making this analytical choice contingent on the data, maybe I would have done the opposite interaction. I would have done the opposite subgroup. I would have said, oh, look, it looks like maybe it works for males. So then this means that there's, under the assumption that the null hypothesis is true, there's these more and more chances to actually end up rejecting
When
it.
you have that analytical flexibility.
Yeah. So
I see.
because it's the choices that you would have made had the data been different actually determine the probability post data that before you had made any of those choices that you would have rejected the null hypothesis. So this is what we can say someone like Nosek and Latin's mean when they talk about this unknown alpha rate inflation. But we're mostly going to be, for clarity, restricting our attention to these cases where the pre-specification makes a difference between a known to be high versus known to be low error rate. How might SAM actually facilitate a severe test? They could do something like this. They say, we would call that a modified Freudian hypothesis that they came up with. And maybe they actually thought of that before looking at the data. So then they might have said, for the 11 variables that end up being significant, okay, these are the variables where if they come up significant, then I'll infer a corresponding genuine effect of the intervention. So these would be the confirmatory p-values. And then for the other 449 variables, they say, okay, I'm going to have a look, I'll calculate the p-value, I might as well, because I'm going to have this data anyway. But no matter what the p-values are, I will not infer that there's a genuine effect of the intervention. So those would be exploratory. And of course, this isn't what you literally write in a pre-registration report, but it's an interpretation of one aspect of the meaning and significance of a pre-registration report, that you're constraining your inferential implications in this way. So now, if SAM had done that, then they'd be following an entirely different testing rule. It would be that if there are 11 or more statistically significant results from just the set of confirmatory p-values, that's just the 11 ones, then infer that these each indicate an important effect. And the relevant error is the same as before. But the set of outcomes possibly leading to making the relevant error is now just this one single set of outcomes in which all the 11 confirmatory p-values are significant. So now the upper bound estimate on the probability that they infer there's at least one important effect of the intervention under the assumption that they are none is 0. My calculator ran out of decimal places, so I'm not exactly sure what it is, but it's pretty low. And just to get a more of an idea of how this works, let's just say only 3 out of the confirmatory p-values came up significant. Well, then they could honestly claim to be following a slightly different rule post hoc, which would be this: if there are 3 or more statistically significant effects from the 11 confirmatory p-values, infer that these each indicate an important effect. And when they do that, then there's still a fairly low probability under the assumption that there's no true effect of the intervention that they would infer at least one true effect. So it would still be a fairly severe test of each individual effect they infer. So now the multiple hypothesis testing police, they just always want to correct for the family-wise error rate of everything, but Sam has a fairly compelling response here, which is that, well, the relevant family-wise error rate that determines whether I have evidence for each of these individual effects is the family-wise error rate for just the 11 confirmatory hypotheses. So I have severely tested each of these individual hypotheses. So now that we see how this error statistical confirmatory exploratory distinction works, we can get to today's little problem, which is agent relativity. So we can imagine Sam is one scientist and Morgan is another, and they both look at the same data set. They have all the same background information, the same calculated test statistics. Sam implements the pre-specified severe test that we just described. However, and Morgan comes along and they have a look at the data. But unlike Sam, if the exploratory effects had come up significant, which they didn't, but if they had, then Morgan would have inferred that these indicated important effects. They would have ignored Sam's exploratory warning. So what this means is that, unlike Sam, under the assumption that there is no true effect of the intervention on any of the outcome variables, Morgan still would have had a very high probability of inferring at least one genuine effect. So this would mean that, according to this confirmatory exploratory distinction, Sam has done a strongly confirmatory test indicating an important effect of the intervention on, say, good school relations. but Morgan has not done a confirmatory test, and they would need to do a confirmatory follow-up study to actually have evidence, to have confirmatory evidence for these individual effects. One slight variation on the example. So now we can imagine that, so Morgan, they wouldn't have inferred that any of those exploratory results indicate a genuine effect, but Morgan is very, very convinced of this modified Freudian hypothesis that says we should just expect the 11 effects. So, and it is the case that those effects came up significant. But if they haven't, unlike Sam, this would have induced Morgan to think, hey, no, this has to be, there has to be another way to demonstrate these effects. So they would have started running more sophisticated models to try to gain a confirmation, to actually be able to reject some relatively similar null hypothesis. And so then there's a higher chance that Morgan would accept that there is at least one important effect of the intervention, assuming that there are no effects. So this means that these 11 statistically significant results are less confirmatory for Morgan than they are for Sam. So what should we make of this? I really don't think it's much of a problem. The interpretation I would make is that, so some people might say, when you're doing, for a particular study, well, the goal of my study is just to tell the relevant target audience how much reason they have to believe that certain claims are true, how much evidence they have. And you might think that evidence should be agent independent. If two people have the same information, they should have all the same evidence about what is true. So what I would suggest is we can just say what Lakens, I believe, already says, which is that my research is not solely aiming to present evidence, but it's aiming to ensure that I and consumers of my research behave in a way that avoids key errors. And so people should listen to my warnings about what's exploratory, and then they will also be able to avoid error in the same way that I do. And this is perfectly fine, I think. However, it's still this little problem, it's still fuel for the fire of someone like, as we said, Mark Rubin, who wants to reject confirmatory exploratory distinction. They might say, no, I'm just trying to provide evidence about what's true. So then maybe they would just use this Fisherian interpretation of p-values. You might have seen this recent, quite controversial paper by Mupp et al., where they are advocating this Fisherian interpretation of p-values as continuous measure of the evidence against the null. And so, unlike on the error statistical view, to my knowledge, there isn't this clear set of rules about how to deal with multiple hypothesis testing if you reject this confirmatory exploratory distinction. But here's what I think might be kind of implicitly characterized how someone would do it if they just post hoc think about what's a reasonable kind of adjustment to make. So you think about what key compatible, minimally plausible mechanisms may have generated the data. Then you try to use a p-value to rule out as many plausible causal mechanisms as possible. Then if you can rule out all the mechanisms, then great, you have evidence for the last one standing. But if there are a few remaining minimally plausible causal explanations for the data that aren't ruled out, then you don't really have evidence for any one in particular. You might take this stance in a particular analysis. And then going back to step one, how would we apply that here? Well, these are the possible causal mechanisms. One says there's no important effect of the intervention predicted by Freudian psychology. The other says there is an important effect of the intervention on just the 11 variables. So these are incompatible causal predictions of the data. And so now the multiple hypothesis testing police can appeal to more or less the same mathematical fact as before, but the answer to the so what question is different. It's something like this principle here, formulated by Mayo and the late Sir David Cox, which is a way to interpret p-values as a continuous measure of the evidence against a causal claim. So a test statistic, such as a p-value, TD adduced from the data, is evidence against the null hypothesis to the extent that if the data were generated by the causal mechanism described by the null hypothesis, this would probably not have produced any test statistic, which is such a bad fit with the null hypothesis as the observed test statistic. So let's apply this principle now. We're going to look at H nonsense here, and we're going to apply this principle to try to rule out H nonsense. So the relevant test statistic would be the number of p-values that were statistically significant. And then we would be saying, is it the case that if H nonsense were true, that it would be very unlikely to observe as many or more as 11 p-values? And no, this isn't the case. It would actually be not unlikely at all to observe as many or more p-values as the 11. So the multiple hypothesis testing police can just use this reasoning, and they can say the data are not inconsistent with what we would expect if they were the results of a causal mechanism that has none of the effects predicted by Freudian psychology. So they do not at all refute this causal mechanism, which is inconsistent with your modified Freudian hypothesis. So you can't claim to have any evidence, or you'd have to rule out competing causal explanations of the data. And interestingly, even if Sam had actually pre-specified, even if these were confirmatory tests, they would have done a severe test. But on this view, you would just say it doesn't matter. I don't care about your personal error rates. The total available data speaks for itself, and you haven't ruled out competing causal explanations of the data, or the data itself doesn't rule out competing causal explanations, so you can't claim to have supported this view. And you might think, well, this sounds like maybe an overly conservative way of doing inferences in some cases, but at least it implies some kind of strong protection against spurious inferences. But really, it doesn't at all, because so if the idea is that we're just going to post hoc, have a look at the data, think about the plausible causal explanations, and then try to rule some of them out and see what's the most reasonable causal explanation of the data, we basically, with sufficient theoretical freedom, which we have a lot of in social sciences, then there's basically limitless freedom to infer some spurious hypothesis. So we can now imagine that Sam has this theoretical insight. So they say, well, I come up with this argument for why Jungian psychology would predict that those 11 effects would be real, and then it says nothing about the 11 effect, the other 449 variables. So you can see that, you know, based on this, we had this kind of set of rules for applying a multiple hypothesis correction. But you can actually, Sam actually is following these rules, because this Jungian hypothesis isn't inconsistent with saying that there's no effect of the intervention predicted by Freudian psychology. So now the multiple hypothesis testing police are still on Sam's case. They're saying, hey, you left 449 variables in the file drawer, what are you doing? But Sam can just say, no, those are irrelevant to my research question about Jungian psychology. And this kind of resembles a position that Mark Rubin has taken. So Mark Rubin says that if you thought of these hypotheses before the data, but then they ended up being irrelevant to the final research question that you answered, well, that's fine. They won't bias those conclusions because they're irrelevant. And I think in response to the kind of issue that we just raised here, Mark Rubin might just say, look, you can just make the your coding and your all of your data and output variables publicly available. And I guess if you can decide for yourself, you think that's sufficient. So there is an error statistical response to what Sam was doing, which is basically we're going to expand the relevant error. So we would want to avoid inferring some kind of psychological hypothesis. We can't say exactly what is in that class of hypotheses, but there's some class of hypotheses that Sam is disposed to use to explain the data, and they're very likely to infer one of them, even assuming that they're all false. So then we could claim that none of those hypotheses are spurious tested. But someone like Rubin, who takes the Fisherian view, they've already rejected that this severe testing idea is relevant. They say, I'm just concerned with evidence, and that's a bad theory about evidence. So it seems like they can engage in this kind of, you might call it p-hacking, with some kind of principle philosophical justification for their views. However, there are fortunately plenty of other reasons to pre-specify that even a Fisherian who just takes the view we've just described should be able to get on board with, and they are all more precise, more specific consequences of these cognitive biases that we see Marcus alluding to here, that I know a number of other researchers at TARG have been describing in your work. So this one is fairly straightforward. You know, it's if we have knowledge that there's this potential to suggest a certain causal claim, and then there are obviously a lot of assumptions that need to be made to substantiate that claim. If we have to justify our assumptions prior to observing the data, there's not the same potential for our arguments that those assumptions are justified to be sort of biased by our knowledge of the data. So this would be, I take this to be the justification for the kind of pre-registered triangulation of evidence strategies that I know you're developing at TARG. And then there's asking the right questions. So Sam's change of question that we saw previously, it seems like they were just doing that, you know, to get a flashy looking result, an easy publication. But if they had to pre-specify their question, they would have had to just think about, well, what question is useful to ask given the societal aims of my inquiry, and there wouldn't be the same opportunity for the kind of selective reporting that we saw. And the final one is a little bit more subtle, and I'm already at 33 minutes, so I'm just going to leave it here. So yeah, thank you everyone very much for listening, and I look forward to any questions you may have.
All right. great. And of course, anybody who is joining online, feel free to put your hand up, or yeah, even better, put your questions in the chat. But do we have any questions from the audience here? Otherwise, well, one question I was thinking of during the presentation here is I know a lot of people in TARG do analyses on large existing data sets like ALSPAC and other things. And would you have any advice from this framework to people who are kind of dealing with these large existing databases, and how that would influence their kind of daily working in formulating hypotheses and running tests?
And I definitely don't really have any advice for how to practically do science in any way, really.
No practical
So
advice.
what I guess this is more practical advice for how best to argue for pre-registration rather than how to use it. I would suggest, I know you've done there have been some nice publications coming out of TARG recently about using pre-registration on secondary data sets. I would suggest that all the points here, I don't see any reason why they wouldn't apply to a secondary data set. But yeah, in terms of practical advice, I mean, maybe there could be some practical advice in this point here, which I wanted to make at the end, which I think maybe is a slightly overlooked point, which is just that if you want to make a general theoretical claim, so there was this recent study, Conclusions et al. They wanted to say something about the replicability in general of applied microeconomics studies. And what they did was they replicated just 2 studies. But you might ask, well, are those representative of applied microeconomics in general? And even leaving aside the sample size issue, maybe do they just implicitly go looking for studies that are a bit fishy, maybe? But they have a very good response to this, which is an example of pre-specifying without actually publishing a pre-registration report. They had this detailed explanation of how did they actually select those 2 studies. So, and this we can facilitate showing that these actually we have reason to expect these would be representative examples of an applied microeconomic study. And it seems like this is something that could be more broadly applicable in the social sciences. You could try to say you have this general theoretical claim, and you're going to look at specific phenomena, and then you can say, well, here's how I've chosen these phenomena. It seems like maybe this kind of thing that we see on the kind of values could be used more often. That's about the only practical advice that I can think of out of this presentation, really. Aside from how best to argue against people like Mark Rubin who want to reject pre-registration.
So what you're saying here is that something that would be applicable to kind of writing like a pre-registration of sorts that isn't necessarily based on kind of particular hypothesis testing?
Yeah, so these 3 benefits that we see here, that I have listed here, these are all examples of something that, to say that this is a benefit of pre-specifying, there's no implication that you don't need to appeal to this framework where we're distinguishing between confirmatory, exploratory analyses, and we're trying to control our error rates. Rather, so for example, we could really just, so in this example, right, what Huntington et al. Would want to show is they would want to say they should probably have had more than 2 studies, it seems to me. But if they had a few studies that didn't replicate, then it would be something like this principle here. What they'd implicitly be saying when they claim that there's a poor replicability across applied microeconomics would be that, well, if the replicability were some reasonable level, then it would be very unlikely to observe such a low number of replications as what we've observed. So that's just an application of this Fisherian reasoning. There's no implication. No one is saying there's any error rate with which we're accepting a hypothesis. So, and then this is just a benefit of pre-specification that doesn't imply this error control framework. So yeah, so then if you do have this reason why you think this error control framework doesn't make sense for some reason, like what I suggested, then you should be, I don't see why you should object to something like this. So it seems like it's a more broadly acceptable argument, I guess, if that makes sense.
I think I've got some of that. Yeah.
I mean, I think part of the problem is that people try to come up with very specific reasons for using pre-registration in a very specific way. And I think, you know, one of the things you drew out is that you can't think of it in isolation. It fits into the whole kind of inferential framework that you're applying to your work, the type of question you're asking, the type of data you collect, the type of statistics that you apply to those data, and then the conclusions that you draw from the statistics. So it's not a single thing, it's part of a system, and it can play different roles, if you like, within different systems, effectively.
Yeah, absolutely. And it seems to me like there's a bit of a tendency to kind of do pre-registration as a box to check, whereas maybe it might be more helpful to emphasize that it's a tool that can be used for various very specific purposes to facilitate a clear argument to answer your research question, right?
And also that it just is part of that general principle of documenting what you do as you do it. So at the point when you do it, you're laying out your hypotheses. When you're making those hypotheses, you're laying out your analysis plan as you develop that analysis plan, and just being as transparent as possible. So, you know, for me, I sort of hold these things quite lightly. I just think they're just good practice that will generally help to improve quality without it having to sort of sit in a particular place that it can never move from.
Yeah, so that's getting into the more, I would like transparency, I would consider to be a positive externality, because you can have what, you know, Mark Rubin says, like he describes it as, I think, contemporary transparency, or something you can just transparently show what you've done without having pre-registered. And I think that, you know, but the transparency that maybe is encouraged by pre-registration, I think it would be a positive externality rather than an intrinsic benefit. And I guess, like I said, I think most of the actual practical benefits of pre-registration are likely to be positive externalities. But as someone who's doing this philosophical stuff, I don't really have too much to contribute towards describing what the extent and significance of the positive externalities, which I'm sure are probably very large. Yeah.
I feel like we could go down to a whole rabbit hole of its own about talking about what is an externality versus the main point of what you're doing. But maybe I'll save that for later in the pub. I do want to ask, how many people here have written a pre-registration for a study? So some decent number. Will, I'm disappointed in you. Yeah, and have you, and I'm curious to know, have you had like pushback from other people wanting, like, from on your team or others, like, have you had any kind of engagement with pre-registration after something has been published? Or like either of those? Helen is nodding.
Oh yeah, I was saying not everyone was super keen on the idea of pre-registering, the thing that we did pre-register at secondary data analysis, and I also had conversations with potential collaborators where they would thought pre-registering secondary analysis was a good idea at all, and it's stalled.
Were any of the arguments, some of the philosophical arguments coming up, or were they more practical?
I think in the case where we kind of gone ahead and done it, everyone was more worried about the practicalities and was it all going to work out, and was that a sensible way around to do it.
Right.
And in the one where it didn't come off and I haven't ended up doing it, it was more probably philosophical stuff of like, but how can I know what the data is going to show and what the data, you know, we haven't looked at the data yet, and I was just, well, I don't think that's the way that I think about data.
Right.
So I don't know whether we got to quite the philosophical terms, but I guess maybe those same underlying ideas of how we to not specify what we're going to do if we certainly do it.
Right. Oh. That's interesting to hear how it actually kind of pans out in practice. Have other people had any kind of barriers to pre-registration that you?
So I don't know if it's a barrier, but we're currently trying to write one for secondary data where we're using, we're going to create trajectories, and that in itself creates a massive barrier for us because we don't know what our categories are because we can't look at data and we don't know what our question necessarily is until we see what the trajectories are or what our hypothesis would be necessarily.
Yeah.
So
like
in
it's
these
something that
cases,
has to go kind of step by step.
But
and
it's,
harder
yeah,
to pre-specify.
the pre-specification, like the way you were describing pre-specification seems actually much more applicable to those kind of settings, saying, well, these are the types of decisions we're gonna have to think about.
Yeah.
But we can't necessarily say specifically what we are going to do. Yeah, it's been a challenging thing to think about.
I think you run into this issue with like AlSpec where some people just know the data set so well, they kind of almost see that, they kind of have seen some relationships come up already because they've just worked with the data for years, and so it's hard to be like, who knows what would happen when we run that analysis.
And I think this is a really important point because that all of this illustrates that it's not a sort of one size fits all, always do it the same way and it'll achieve the same thing, which is why you need to think about, so how does this fit within what I'm trying to do, context of my questions, the type of data, etc., and what you're trying to achieve with it. And sometimes it is just laying out as best you can what your assumptions were from the outset, recognizing that they might change. I mean, another misconception about pre-registration is that you're never allowed to deviate from it. Of course, you can, you just don't say that you have and why. And, you know, again, that's part of the transparency bit.
Yeah, but of course, we're also supposed to look kind of incredibly clever, and you know, every hunch we have has to be correct.
It's very unlikely. Of course, obviously, the Freudian people would just be like, well, not everything that's reported can be measured, not everything.
Yes, I did enjoy that you involved Freudian and Rubian.
We have one question from online, and it's from Benjamin Wolf. He says, thank you for the talk. Could you please quickly re-go over the argument for what is wrong with evidence being relative to who is the speaker?
Oh, yeah. So basically, it's not, you can reject this argument if you want. This is one of those cases where it's more a matter of intuition. All I really said is that you might think that if two agents have exactly the same information. So in this case, you know, Sam and Morgan, they know they have the same data, they've calculated all the same p-values, and they're looking at the same hypotheses. And they also, we can assume they know what one another's inferences to draw dispositions, to draw inferences, what one another's dispositions to draw inferences in response to the various possible data items are. So they have the exact same information. A lot of people might say, well, they should have the same reason to believe that certain things are true. And I think you're free to reject that and say that it is evidence. You know, but even if you do say, even if you do reject the view that a superior test, as defined by Deborah Mayo, is a criterion for evidence, what you can say is you can think of it as a refinement of what exactly we should want to, what exactly do we mean when we say we want to control our error rates. And Mayo's given like a nice, precise description of what it means to really control your error rates. And then you can say, sure, I just have multiple goals of my inquiry. One is to control my error rates, and then people can also look and find obviously evidence by seeing the information I present as well. So in that sense, I don't really think it is a problem, but it is definitely a reason that I think will appeal to a lot of people to want to try to just reject the error control framework. Does that help, or should I? Is there any more issues?
Nothing yet.
Yeah, I think Benji, if you have any more questions, okay. Maybe we can bring it up on another referee. Sure. I think we should finish up for now. So thank you again, Eoin, for the lovely talk, and thank you all for coming. And we can give another. Before we disperse, does anybody have any announcements or things to bring up for the group while we're assembled here? No. If anyone from Zoom, if you have anything to announce to the group, you can make a little note in chat. Otherwise, I'll assume that there's nothing.
Could I quickly mention that? Yep. Peter and I are working on the PPI section of the website, and we'd really appreciate any comments on if you go to the PPI Slack channel. We posted in the PPI Slack channel a little kind of description of what we're planning to put on the website. So if you are planning on doing any PPI anytime soon, please join that Slack channel.
Could you
also
remind
feedback.
people what PPI is in case they don't know?
PPI is patient and public involvement, which essentially means getting members of the public involved in your research kind of from the beginning or throughout your project, not participating as a participant, but actually helping to shape your research and communicate it to the public.
Great. Okay, thanks, Jazz. Yeah, so we should look on Slack. for that.
Please,
Okay,
that'd be
great.
Thank you.
Thanks a lot. Otherwise, I think we have a lab meeting next Friday as well, which is, I forgot who that is.
It's Angela next week.
Okay, great.
Oh,
And that
this-
will be in person or blended?
That'll be blended too, so people can come. Just one other thing, we've got quite a few new people coming next week. So we've got a new visiting academic called Dela. And we've also got 3 master's students. So they'll be here on Tuesday. So if you see them around, just say hello. And make them feel welcome. So Dela will be in 3D14, and the master's students, we've got a hot desk for them in my office, which is 5D11.
Great, well, what?
Oh, you're also joining in 2024. Is that right?
Yeah, so I've been discussing this with Marcus. There's some plans for me to do some kind of work. It's a little bit to be determined what exactly will involve. I'm also applying for a grant, so I haven't quite got that yet, but I'm hoping I will get the grant to extend my PhD funding. So yeah, planning to poke around and ask people a few questions maybe in 2024.
To do lots of pre-registrations, so that's something to look into. Great, thank you all for coming. And for those of you who want to go to the club afterwards, I guess we'll be at the hybrid from probably 4:30 or 5. I'll post on Slack on the social channel when we head out. And yeah, I think it should be probably a nice evening, so might be a good chance to get some socializing in. All right.